Alright, so number 12 is probably one of the more complicated word problems to set up on that worksheet. So what we have going on here, we have a park. We want to plant a uniform border of tulips inside of that rectangular garden. And the rectangular garden has dimensions of 18 by 12. And what we're being told is that we want the area of the border to be half the area of the garden. So we want to know how wide the inside of the border should be to one decimal place. So again, it's a little bit tricky to set up, but to start off here, what we have is a rectangular garden. So I'll draw that to start. So there's a rectangular garden, and we know that this garden has dimensions 18 meters by 12 meters. So let's write that on there, 18 meters by 12 meters. Okay, and this is what can get a little bit trickier to try and visualize here. So we want to plant a uniform border of tulips on the inside of this garden. So we're going to have a border along the inside. It looks something like this. Let's try that again. Okay, and the one thing that's really key in here, and it's an easy word to gloss over in the problem, the fact that it's a uniform border. The fact that it's a uniform border tells us it's the same distance from the edge on all sides. So it means this distance right here, which I'm going to call x, is the same as this distance right here, the same as this one, and the same as this one. So it's the same distance from the edge all the way around. So x is going to be the width of that border. So we should define our variables then. Okay, so we're going to let x represent the width of the border in meters. So this is essentially what's going on. Now it says we want the area of the border itself, so the area of just the border, so the part I'm just going to shade in here. Okay, the area of just the border is going to be half the area of the entire garden. The area of the entire garden is 18 by 12. How wide should the inside of the border of the tulips be to one decimal place? So let's just think about the area of the border first. So we need the area of the border to be equal to half the area of the whole garden. Okay, so we need to figure out what each of these is. Now, for starters, let's work with the area of the garden. That's a little bit easier. Okay, so the area of the garden is just going to be 18 by 12. So let's call that AG for area of the garden, and it's going to be 18 meters by 12 meters, which when we simplify is going to be 216 square meters. Okay, so that part we know. The area of the border is a bit more complicated, because if you want the area of just the yellow shaded part right here, it's going to be the area of the outside minus the area of the inside. And the area of the inside is a little bit trickier to figure out, but we can figure out the dimensions here, because if you know that the length of the entire length is 18, well, what's different right here? Well, we have our 18 meters, but what we've lost is a length of x on one end and a length of x on the other end. So the length of this entire inside part here is 18 minus 2x. Okay, similarly we can look at the width and say, okay, that entire width is 12, we've lost an x off the top and an x off the bottom, so the width is going to be 12 minus 2x. So the area of just the border is going to be the area of the outside, which is 18 times 12, minus the area of the inside, which is 18 minus 2x times 12 minus 2x. So for the area of the border, I'm going to write out 18 times 12, so the area of the outside, okay, minus the area of the inside, which is going to be 18 minus 2x, times 12 minus 2x. So all I'm doing is taking the area of the outer rectangle and subtracting the area of the inner rectangle. Okay, and all that's going to be equal to is half the area of the garden, which is half times 18 times 12, which we said was 216. Okay, so this is my quadratic equation that I have to solve. And again, it looks very, very messy. It looks like there's no way of solving it, but again, any quadratic equation, you want to get everything over to one side so it's equal to 0. So what I need to do is expand everything out here and simplify, which can take a little while, but again, it's just algebra at this point, and we should be able to solve this one. So let's simplify it piece by piece. So 18 times 12 I know is 216. Okay, and I'm going to expand out 18 minus 2x and 12 minus 2x in an array. Okay, so put it all together, I should get 4x squared minus 60x plus 216. Okay, and the right side of the equation, half times 216 is 108. Okay, and then again, just simplifying a little bit further, I'm going to have to run this minus sign through this bracket, because remember, this entire thing was this binomial that was multiplied by the other binomial, it was all being subtracted from the outside area. So I need to run that negative sign through. So that's going to give me minus 4x squared plus 60x minus 216. Okay, at this point, it's all about collecting my like terms, getting them all on one side of the equation. Okay, so I can see right now that these are going to cancel out. So I'm going to be left with negative 4x squared plus 60x minus 108 equals 0. Okay, so I have my quadratic equation in standard form, it's equal to 0 on the other side. So now I need to find the zeros either by factoring or using quadratic formula. I'm going to see if the discriminant is a perfect square to see if it factors. So it's going to be 60 squared minus 4 times negative 4 times negative 108. Okay, b squared minus 4ac. Okay, so the discriminant is equal to 1,872, which I can check if it's a perfect square, and it is not a perfect square, so this does not factor. So my best method here is to use quadratic formula. Okay, so let's do that. X will be equal to, so negative b is going to be negative 60, plus or minus the square root of b squared minus 4ac, which I already calculated over here. It's 1,872. All over 2a, and 2 times negative 4 is negative 8. Okay, so that will give me, again, two possible answers. I need to examine both of them to see if they make sense. So I'm going to have one at negative 60 plus the square root of 1,872 all over negative 8. Or x is negative 60 minus the square root of 1872 all over negative 8. So I'm going to have to run both those through my calculator and see what I get for each one. Okay, I'll leave you to check these yourself, but you should get two possible answers. X is approximately 2.1 or x is approximately 12.9. So you need to ask yourself, are both these answers valid? And on the surface you might think yes, why couldn't both these answers be valid? They're both positive and they have a length. Okay, but it's not just that we're looking for negative values that can't be length. You have to look at the original problem. So let's just say x is equal to 12.9. Go back to our original diagram here. Is it possible that we're taking 12.9 meters off each edge when the width is only 12 meters to begin with? Absolutely not, because taking off one of those values would be more than the length, more than the width of the entire garden. So it's actually not possible to take off 12.9. The other way you could think about it is you put 12.9 into this dimension for x, 18 minus 2 times 12.9 is going to be negative. So even though the value of x itself is at negative, it would give you a negative length for the area of the inside, for dimension of the inside garden. So this particular one here, x equals 12.9, is invalid or inadmissible. Okay, so the only possible answer is going to be x equals 2.1. We can do a quick check over to see if it makes sense. Does 18 minus 2 times 2.1 give you a feasible value? Yes, it does. Same with 12 minus 2 times 2.1. So the only possible answer here is that the width of the board is going to be 2.1 meters on all sides. Okay, let's try one more. So we have a football punted into the air. Its height in meters after t seconds given by the equation that's given there, negative 4t squared plus 24.5t plus 1. Find the maximum height of the ball, and they want to know when the ball reaches its maximum height. So the nice one about this one is they're already giving you the equation. You just need to figure out what you're being asked to find. Okay, so as I write out the equation here, think. It's asked for the maximum height of the ball, okay, and when it reaches the maximum height. So once you see the maximum height, you know you're thinking about the optimal value, and you want to know when it reaches the maximum height, so you're actually looking for the axis symmetry. So basically, you have an equation in standard form, you have to find the vertex. okay, the axis symmetry and the optimal value. So the quickest way to find the axis symmetry is to use that formula I showed you, that x equals negative b over 2a for the axis symmetry. You have to be careful here because, again, our variable is an x, it's t, but remember that a and b are just the coefficients in standard form of here and here. So we have our a being negative 4, our b being 24.5. So what we're going to have here for our axis symmetry, in this case, is going to be t. The t is going to be equal to negative 24.5 over 2a, which is 2 times negative 4. Okay, so if we run that through our calculator, we should get approximately 3.06 seconds. Okay, and it's said to round to the nearest hundredth of a meter, which is 2 decimal places. So we're going to take that as our t. Okay, so that's given us one part of the problem. Now you have to find the actual maximum height. Well, we know that's going to occur after 3.06 seconds, so you can sub that value for t into the equation and then solve for h. So what we're going to have, h is going to be equal to negative 4 times 3.06 all squared plus 24.5 times 3.06 all plus 1. Okay, so let's run that through our calculator. And again, round it to 2 decimal places, the nearest 100th. So 2 decimal places, I get 38.52 meters. Okay, so again, since you're given the equations, this one's actually not too bad to do. It's just really asking you to find the axis symmetry and the optimal value from standard form, and we have lots of tools of doing so. Okay, if you don't remember the x equals negative b over 2a to get the axis symmetry, you could always use partial factoring or completing the square to get into vertex form. Okay, the other thing you could do, if this one does have zeros, you could solve for zeros and use those to find the axis symmetry, but that takes a very long time. Okay, so that's it for this one, and if you need more help, we'll see you in the future videos.